In this example, we're going to look at break-even analysis. In a typical situation, a manufacturer wants to look at how many units of a certain commodity or item have to be sold in order for his total revenue to equal the total cost. This lets them know what their goal would need to be so that they start making money, or in a worst case scenario where they're going to start losing money. So let's look at an example from the text that you can follow along. In your text, I'm working from page 59. I'm going to look at problem number 37. In that problem, we have Julia who can sell a certain product for $110 per unit. The total cost consists of a fixed overhead of $7,500 plus the production cost of $60 per unit. So what that means is, right off the bat, she has to spend $7,500 just to be in business. And it costs her $60 for every unit that she has to make. So that's how much it costs her to be in business. But she can sell each of those products for $110. So as we work this problem, the first thing we're asked to do is to express Julia's total revenue, her total cost, and her total profit in terms of X, the number of units sold. We're also asked to sketch the total revenue and total cost functions on the same set of axes. The reason we want to graph those on the same set of axes is so that we can see where those functions intersect. Now, the point of seeing where those functions intersect is because that will give us a visual of that break-even point. When we see where they cross, we see where the cost function and the revenue function meet and where that revenue or profit or the loss starts to happen. So let's take a look at how we write the total revenue function first. Let's use the information that we're given in order to determine the revenue function. Now we're told to work in terms of X. So revenue means how much money is Julia earning per unit. So for every unit that she sells, she is getting $110. So her revenue function, let's call it R, she's earning $110, that's a dollar sign, every time she sells one of her units. So that's your revenue function. Every time one of her widgets sells whatever it is that she's selling, she gets $110. So that means she would multiply 110 times that X in order to figure out how much she's going to make every time one of her widgets sells. So there's your revenue function right there. It's as simple as that. Our next task is to determine the total cost function. How much does it cost her just to be in business? Often that's the hardest part of being in business, is the cost of being in business. Well, let's let our cost function be represented by C. C of X. The cost in being in business to produce X, our widgets. Well, to be in business, to open up, to turn the lights on, it costs us $7,500 just to come in every day. And then for each widget that we produce, it costs us $60. But not just $60 one time, we have to pay $60 for every widget that comes off the assembly line. So we would have to multiply 60 by that X. That X isn't a multiplication symbol, it's a variable X. So there's our cost function. All done. Now let's write our profit in terms of X. Our profit function. How do we determine profit? Well, profit is how much money we make after we sell our widgets and we pay our cost. So let's just write down what profit is and then see if we can write our profit function. So profit is how much we make after we pay our costs. So it's how much we make minus our cost. How could we write that in terms of our revenue function and our cost function that we already have? I think we could take our profit function and write our revenue minus our cost function, and then we would have our profit function. So let's write our profit function doing that. So our profit function will be our revenue function, which we already determined to be $110 for every widget, minus our cost function. But it's our whole cost function, so let's put that in parentheses. Remember our basic rules of algebra. We need to subtract that entire function. So let's get that out of parentheses by distributing this minus 1 that's there. So we have 110x minus 7500x, or no x, plus 60x. So that becomes plus 60 because we distribute the minus 1. Ultimately, our profit function becomes 50x minus 7500. So now we've written our profit function as well. So finally, the last thing we have to do is sketch these two functions together on the same set of axes. Notice that I've sketched both lines on the same set of axes. Recall how to graph a line. You've got your cost function, which is c of x equals 7,500 plus 60x. So essentially that's telling us, if we want to think of that in y equals mx plus b form, let's look at it like that. That's telling you that your sorry, I need to erase that. That's telling you that your slope is 60 and your y-intercept is 7,500. So look at your graph. Here's your y-intercept right here at 7,500. So you're moving a slope of 60 over 1 for your cost function. And that's this line right here. So then if you plot your revenue function, which we said was r of x equals 110x, well, that's actually plus 0, so your, let's do that in y equals mx plus b form as well. That's 110x plus 0, so then your y-intercept is 0, and that slope is 110 over 1, so that's this line right here. And so here's your point of intersection. Now I recommend using a graphing utility. You can use something online, you can use a graphing calculator to plot these, but here's how you would enter them in. You would just put these values into a graphing calculator or an online graphing calculator. One that I recommend, I love, is wolframalpha.com. So spell it out, W-O-L-F-R-A-M-A-L, oh, my thing's moving here, A-L-P-H-A.com. If you go there, you can type in anything and it'll solve it or graph it and tell you what your points of intersection are. So it's a fabulous site. It'll do so much more than just graphing. It does every subject, actually. But anyway, that's a fantastic resource if you ever need it. All right, so let's move on to the next part of the question. Once you've written all of your functions, we want to use that information then to really get to some important parts of business. People want to know how many units must be sold in order to break even, which we've already seen from the graph, but we don't even really have to graph it to find out that information. We can figure it out algebraically, which is really cool. So let's see how to do that algebraically. We have two options for us. We can either use our profit function or we can use the cost and revenue function, and I'm going to show you both ways. Okay, so how many units must be sold in order to break even? So in order to use the profit function, breaking even means we got a profit of 0. So using that profit function, we just set the profit function equal to 0 and see what x equals. So using the profit function set equal to 0, we would just go 0 equals 50x minus 7,500 and solve for x. So we would have 7,500 equals 50x, and divide both sides by 50, and you get x equals 150, which, conveniently enough, if you go back to our graph on the previous page, that was the intersection point we saw for x. X intersected, the two graphs intersected at x equal to 150. Our other option to see where we broke even is, this was our first option, the other option that we have is to set the cost function equal to the revenue function and see where those two things equal. We'll come up with 150 again, but just in case you don't have your profit function written up, if you just have your cost function and your revenue function, you can use those. So let's just see what happens when we do that. So if we take our revenue function and set it equal to our cost function, let's see what happens. So if we take 7,500 plus 60x and set it equal to our cost function and solve for x, let's see what we get. We're going to get 7,500 equals 110x minus 60x. So we're going to get 7,500 equals 50x, which we've already determined x equals 150. So at 150 widgets, that's where Julia's going to break even. So what is the profit or loss at 100 units sold? So if there are only 100 widgets sold, will Julia make money or will she lose money? How can we determine that? Well, that is what our profit function is for. It's the profit function. It tells us whether we're going to profit or not. So if we take our profit function and evaluate it at 100 widgets, then we'll know whether we're going to make or lose money. So let's take our profit function and determine what we're going to have at 100. So we're going to have 5,000 minus 7,500. And we end up with a negative 2,500. So since we ended up with a negative value, that represents a loss of $2,500. So if she only sells 100 widgets, then she's going to lose $2,500, which we've already determined she's got to sell at least 150 before she breaks even. So until she sells 150, she's not going to start making any money. So our last task is to determine how many widgets must be sold to realize a profit of $1,250. So to realize a profit of $1,250, we want to figure out what x is going to give us a value of $1,250, a positive value of $1,250. So again, we're going to use our profit function, and we're going to see what it will take to make it equal $1,250. So we're going to take this profit function. Once again, this is a very handy function, and we're going to see what it's going to take to make it equal $1,250. So if we just set it equal to $1,250 and solve for x, then we can determine how many widgets we need to sell in order to have a profit of $1,250. So let's add 7,500 to both sides, and we end up with $8,750. equals 50x. Divide both sides by 50, and we end up with x equals 175 widgets. So in order to get a profit of $1,250, she will need to sell 175 widgets, which makes sense because we knew we needed to sell 150 widgets just to break even. So then she's going to need to sell 175 to make a profit of $1,250.